Welcome back to Applied AI Engineer. So far at last talks, it produces sentences. But software doesn't run on sentences, it runs on data with a known shape. In this episode we make at last return structured, machine-usable output you can feed straight into a database, an API, or another function. We'll define a schema with Pydantic, get reliable JSO out of the model using tool calling, and build a validate and retry loop that catches a bad reply and fixes it. By the end you'll have a resume extractor that turns messy text into a typed object you can trust. A quick recap of the thread so far. In episode 1 we made our first API call and met its 4 moving parts. In episode 2 we turned vague instructions into reusable, version-controlled prompt templates, so our prompts became real engineering artifacts. Those gave us good text. Today we go one level deeper. We make the output structured, with a guaranteed shape, and we validate it. That's the step that turns Atlas from a chatbot into a component the rest of your system can depend on. Here's the problem we're solving. Ask a model for data and it answers like a helpful human, a friendly preamble, maybe a markdown fence, then the JSO you wanted, then an offer to help further. To extract the data you start splitting strings and writing regular expressions. It works on your 3 test inputs. Then production sends the 51st input, the model phrases it slightly differently, your parser misses, and something downstream throws an error at 2 in the morning. The root cause is that there was never a contract, just a hope. Picture the fragile version. The model emits prose mixed with JSO. In the middle sits a red box of string hacks, splits, regexes, fence stripping that you hope handles every phrasing the model might choose. It feeds a database or an API that expects exact fields. The whole chain is only as strong as that red box, and the model controls its input. Our job this episode is to delete that red box and replace it with a contract the model is forced to satisfy. The fix starts not with the model, but with us declaring exactly what we want. We write a schema, a precise, typed description of the data's shape. In Python the standard tool for that is Pydantic, and because the Anthropic SDK already depends on it, it's installed and ready. Let's define the shape of a past resume. This is the contract. Each field has a type, name is a string, years is a number, skills is a list of strings, and field lets us attach constraints and descriptions. Notice the nested job model. A resume contains a list of jobs, each with its own shape. The GE and lay constraints say years can't be negative or absurdly large. This one class is now the single source of truth for what a resume is. Everything else in the episode references it. A Pydantic model does 2 jobs from one definition. First, you can add your own business rules with a field validator here. An email must contain an @ sign, a check the type system alone won't make. Second, and this is the trick that powers the whole episode, the same class can emit its own JSO schema by calling model JSO schema. That gives us a machine-readable description of the contract, which is exactly what we'll hand the model so it knows the shape to produce. Running it, here are the top-level fields Pydantic derived. Name is a string, email is a string or null, skills and jobs are arrays, total years is a number. And it computed which fields are required versus optional. Name and total years must be present, the rest have defaults. We wrote Python, Pydantic produced a precise, language-agnostic schema. We didn't handwrite a single line of JSO schema, and it will never drift from the class. Before we bring the model back in, let's make sure we understand what validation actually buys us. The point of a schema isn't just documentation, it's a gate. Data that fits passes through as a typed object, data that doesn't is rejected with a precise reason. Let's see both halves of that. Here's the gate in action on a deliberately broken payload. The years field is the word 3 instead of a number, and total years is negative, both illegal under our schema. We call model validate and catch the validation error. Crucially, we don't just learn that it failed, we loop over the individual errors, each telling us the exact field path and what's wrong with it. Hold on to that precision, it's the ingredient that makes the retry loop work in a minute. 2 outcomes. The clean payload passed into a real object, note years, became the float 5.0, Pydantic coerced types where it safely could. The broken payload raised exactly 2 errors, each pinpointing the field, jobs 0 years isn't a number, and total years must be at least 0. This is gold. A vague invalid output is useless to a model, but jobs 0 years must be a number is something it can act on. That's our bridge from validation to self-correction. Now we bring the model back, and we do not ask it nicely for JSO. We use tool calling. Instead of telling the model please reply in JSO, we give it a tool whose input is our schema, and we force it to call that tool. Its arguments come back as a clean structured object, no pros to strip, no fences to pee. This is the reliable path to structured output. Here's the mechanism end-to-end. We take our Pydantic schema and call model JSO schema to turn it into a tool definition. We pass that to the model in the tools list, and we set tool choice to force the model to call it. The model responds not with pros but with a tool use block, whose input field is a dictionary keyed exactly by our schema. We pull that dictionary out and validate it. The red box of string surgery is gone, the structure arrives structured. Building the tool takes 3 keys, a name the model will call, a description so it knows what the tool is for, and the input schema, which is simply our Pydantic model's JSO schema, dropped in verbatim. This is why we generated the schema earlier. There's no second copy of the field definitions to keep in sync. The tools contract and the validation contract are literally the same object. The system prompt keeps Atlas honest, extract, don't invent. And here's the call. We pass the tool in the tools list, and tool choice with the tool's name forces the model to use it, it can't wander off into pros. When the response comes back, we find the tool use block and read its input, which is our structured dictionary. Then, and this line is the whole philosophy of the episode, we validate it before returning. We never trust the model's output directly, we run it through the contract first. Out comes a typed resume. We feed it a messy paragraph, Priya's resume written as loose prose, with an email, a stack list, and 2 jobs described in passing. Out comes a clean, validated resume object. The model read spent 3 years at Zomato and produced a job with years equal to 3, it pulled the skills into a proper list. This is a real reply captured from Claude. Messy human text went in, structured, typed, machine-usable data came out, and it already passed our schema. Tool calling is reliable, but reliable is not the same as perfect. Once in a while the model returns something that satisfies the JSO shape yet violates a business rule, a negative total, a number written as a word, a required field left out. In a pipeline that runs thousands of times a day, once in a while still happens, every single day. So instead of merely failing, we build a loop that turns each failure into a second, better attempt. That's the next piece of reliability. The loop is simple and powerful. Call the model, validate the result. If it's valid, return the object done. If it's invalid, we don't throw our hands up. We take the exact validation error and feed it back to the model as feedback, asking it to fix only that. Then we try again. We cap the attempts, say 3, so a genuinely impossible case fails loudly instead of looping forever. Most malformed outputs are corrected on the very next attempt because the error message tells the model precisely what to change. Here's the loop in code. On each attempt we call the model, passing in any feedback from the previous failure and try to validate. On success we return immediately. On a validation error, we turn those precise error messages into a feedback string and stash it for the next pass. Notice how the validation errors flow straight into the next prompt. We are closing the loop with the model. And if we exhaust our attempts, we raise a clear error rather than returning garbage. Fail loud, never fail silently. And this is the loop earning its keep. To make the demonstration deterministic, we drive it with a stand-in that returns a broken payload first, then a corrected one once it sees the feedback exactly the failure mode the real model occasionally shows. Attempt 1 is rejected, with both problems named. The feedback goes back, and attempt 2 validates cleanly. The caller never sees the bad data, it only ever receives a verified object. That's the difference between code that works in a demo and code that survives production. We just built tools, parsing, validation, and a retry loop by hand, and that was deliberate, so none of it is magic to you. But from the RAG episodes onward we build framework first, and LangChain wraps this exact pattern into a single call. Let's see how short it gets, knowing now exactly what it's doing underneath. Here's the same extraction in LangChain. We wrap a chat model and call with structured output, passing our very own resume class. That single line does everything we just wrote. It converts the Pydantic model into a tool schema, forces the tool call, pulls out the arguments, and validates them into a resume instance. Invoke returns the typed object directly. It's clean, but because we built it by hand first, you know there's no magic here, just our pattern packaged up. That's the right way to use a framework. And the result is the same kind of validated resume we got from the raw SDK, a typed object, ready to use, with the validation already done. This output is representative of the raw SDK run we captured earlier. The framework and the hand-built version converge on the same structured answer because they do the same thing. When you reach for with structured output in later episodes, picture the tool and validate loop running quietly inside it. A quick note on portability, because you'll meet both. Anthropic calls this tool use. You pass an input schema, force the call, and read a tool-use block whose input is already a dictionary. OpenAI calls it function calling. You pass a parameters schema, force the call, and read a tool calls list whose arguments are a JSON string you still have to pass. Different names, slightly different envelopes, identical idea, give the model a typed function to call. And LangChains with structured output hides that difference, just like our LLM.py adapter from episode 1. To make the comparison concrete, with Anthropic, the tool-use block's input is already a parsed dictionary, so you go straight to validation. With OpenAI, the arguments arrive as a JSON string, so there's one extra JSON loads step before validating. In both, the recipe is the same: pass the schema, force the call, then validate with Pydantic. That final validation step is provider independent. No matter which model produced the data, the contract is yours, and it's enforced on your side of the wire. A few hard-won tips before we wrap. First, write real descriptions on your fields. The model reads them as part of the tool, and a good description noticeably sharpens extraction. Second, prefer flatter schemas. Deeply nested structures are harder for the model and raise the malformed output rate. Third, use temperature 0 for extraction, because you want the same structure every time, not creativity. And validate once, right at the boundary where data enters your system, then let clean, typed objects flow freely through the rest of your code. Step back and see how far Atlas has come. In episode 1, it was a single call returning free text. In episode 2, we gave it reusable, versioned prompts. Today it returns validated, structured objects, which means, for the first time, other code can depend on its output. A function can take Atlas's resume and rank candidates. An API can return it as JSO, a database can store it field by field. Atlas crossed the line from a thing you chat with to a component you build with. That's a real promotion. Let's recap. Free text breaks pipelines, so we wrote a contract with Pydantic. We got reliable structure not by begging for JSO but by forcing a tool call, and we validated the result rather than trusting it. When the model slipped, our retry loop fed the precise error back and let it correct itself. And we saw that LangChains with structured output is just that whole pattern in one line. Next episode we tackle long context and documents, token counting and budgeting, chunking, the summarization patterns, and prompt caching, so Atlas can read and reason over files far bigger than a single prompt. See you there.